All right, Unit 2, Lesson 7, Skill 3 on page 2. Multiplying radicals with negative radicands and complex numbers. Then simplify. It's very important when multiplying radicals with negative radicands, we first express them in terms of I. Since the product rule for radicals doesn't hold for complex numbers. That last sentence is kind of talking about these right here. The product rule says you should be able to, because they're the same index, you should be able to put them under the same radical sign, multiply them, and get that. That is not the answer. So order of operations for radicals that have negative radicands say that you must take out the I first. Okay, so then you have I times I, which is I squared, which is negative 1. Then you can go ahead and put the positive radicands together, get your positive 14, but negative 1 times the square root of positive 14 turns out to be negative 1 times the square root of 14. So this way is incorrect. So that's what it means, but the product rule for radicals does not hold. Okay? So always take the I out first. I times I is I squared, which is a negative 1, since square root of negative 1 times the square root of negative 1 is negative 1, right? The square root of 2 times the square root of 2 is the square root of 4. 2 times 2 is 4, which is 2. Okay, so if you take the square root times the same thing, you'll get what's in there. Okay, so that still holds. So let's look at this one. So the other examples, real times real is 21. I times I is I squared. Therefore, 21 times a negative 1 is a negative 21. Okay. Get all this other stuff out of the way. All right. Remember, when you have anything square that's in parentheses, you want to write it twice, right? It's not just distributing that 2. That's not how you do those for anything complex or irregular. So we want to FOIL these. So 8 times 8, 64. Negative 40i. Negative 40i. Negative times negative is a positive. 5 times 5 is 25. I times I is I squared. Okay. Then we combine like terms and get 64 minus 80i. Right? When you're adding, we don't change the, I wouldn't call it a variable. We're not changing the I or a variable when you're adding terms. And 25 times I squared, that's 25 times the negative 1, is negative 25. 64 minus 25 is 39. That's my final answer for those. Okay? So, negative 6 times, negative 3 times 6, negative 18, I squared. Negative 18 times negative 1 is 18. 15i, negative 50i squared. 15i minus 50 times negative 1. 15i plus 50. Show some work to keep nice and straight, one thing at a time, okay? 15, negative 5i. I think it's a good practice to show your foiling. Positive 2 times a negative 1 is a negative 2i squared. Combine like terms. Negative 2 times a negative 1 is a positive 2. 15 plus 2 is 17 minus I. You can put 1i, but it's, remember, that's just like, that's, x is the same as 1x. I is the same as 1i. So we really don't put that 1 in there, okay? 7 times 7 is 49. Negative 21i. Positive 21i. negative 9i squared. So 49, and then a positive 21i minus a negative 21. So anyway, those cancel out, right? Same thing plus, same thing minus. So this is a negative 9 times a negative 1, which is a plus 9, which is 58. These are changed to negative 1 and 4. That's an I, that's a 2, so that's a 2I. All right, this one here is a negative 1 and a 9, so that's an I and a 3, so that's a 3I. So this is 6i squared, which is 6 times a negative 1, which is negative 6. Okay. This one here has a negative 27, square root of negative 27, so let's change that to negative 1, pull out the I, and that's a 9, and that's a 3. So this is an I, a 3, and a square root of 3. So the problem, I'm going to write it farther over here, negative square root of 3 times square root of 3 minus 3i square root of 3 after that negative 27 is converted. In this case, it's actually, if you didn't notice that and you didn't do that and you just process everything correctly, you will get the right answer, but that would be not the case all the time, so make sure you're trying to process those radicals. If there's a negative, express them in terms of I first. Okay, so this would be a negative 1 square root of 9. This is an odd one, isn't it? And positive 3i square root of 9. All right, so this right here is going to be what? Negative 3. And that's a 3. So 3 times 3 is 9i is the answer for that one. That one's a little tricky. All right, so those need practice. All right, simplify complex radicals and reduce fraction forms when necessary. Step 1, we must first express any negative radicands in terms of I and simplify the radical if possible. Then reduce the fraction by the greatest common factor, and we'll talk about step 2. So let's look at this first one here. So that's a rational expression, in other words, a fraction, big fraction, right? It also has a negative radicand in its square root, so that has an imaginary number. So that needs to be taken care of first. So this is, here, let's do it down here, 100, right? Perfect square that's in there as a factor. It also has the negative 1, also has a 2. So this is an I, that's a 10, and that's the square root of 2. So that's where that comes from. Keep this negative right here, okay? So that's step 1. Now, you have a fraction. All fractions must be reduced. So it says reduce the fraction by the greatest common factor. I personally start with the greatest common factor in terms of the complex number in the numerator. So a 15 and a 10 have a factor of 5 in common. That's the greatest common factor that the numerator has. So I take that out. So when I take that out, I put the rest in parentheses and reduce those two terms by 5. So for negative 15 divided by 5 is negative 3. Negative 10i divided by 5 is negative 2i. Keep that square root of 2. All right, we're just talking we are only talking the real parts. Well, we're only talking about, don't take it out of the radical. I already simplified the radical, so don't take anything out of there, okay? But we're allowed to, at that point, take the 5 out of the 20 at the bottom. All right, so that is our final answer there. All right, so step 1, take out the I and simplify the radical. So 250, let's see, there's a 25 in there, right? 25, and there's a 10 in there. So this is the I, this is a 5, and that's going to stay. So rewrite I'm going to write way over here. 20 plus 5i square root of 10 is what the numerator turns into. Okay? GCF out a 5 out of the numerator. Oops, it's not a 20 anymore. Hang on. That was a 10. Okay, so 5 out of 20 is 4 plus 5i square root of 10. Do not take it out of the radical. Okay, over 5. That reduces away. So my final answer is 4. Oop, I forgot to take it out of the 5 too. Oh man, sorry. Can't talk and write at the same time. My apologies. 5, 4 plus I square root of 10. 5. So take it out of this term and this term here. Okay? Reduce it this way. Final answer, 4 plus I square root of 10. Let me check my key. Yep, that's what that says. Okay? All right, let's hope that I'll do better on the next one. Woo, 432. It's negative. Going to take out the negative 1. 432, big number. 11 squared is 121. 12 squared is 144, which is even. Let me try that one. So 144 into 432 goes 3 times. All right, so that's I. That's 12. And we're going to keep the square root of 3. So negative 16 plus 12i times the square root of 3. Okay? So, greatest common factor out of 16 and 12 is 4. So let's take out the 4. That leaves me with a negative 4 plus 3i square root of 3 over 12. Take out the 4. So my final answer is negative 4 plus 3i square root of 3 over 3. Okay. This one over here, 6 plus the square root of 32. That's needs to take the 1 out. 16 and 2, right? So that would be I, 4, and the square root of 2. So 6 plus 4i square root of 2 over 4. Greatest common factor would be a 2. So 3 plus 2i square root of 2 over 4. Reduce. That leaves the 2 on the bottom. Final answer, 3 plus 2i square root of 2 over 2. Nothing else can come out. I think of it as a 3-ray reduction. This has to come out of here and this has to come out of here. Those are the 3 numbers that we're looking for that have a factor in common. If that 3 had been a 2, I could reduce some more, but I can't. So that would have changed that number right there. So that's the best I can do, and we're never reducing out of the radical, which has already been taken care of. Okay? This is not a whole 2. This is a square root of a 2, which is way less than a 2. So that's not the same number, so don't take it out of there. So that is the final answer for that one. Okay?